Nitrosamines are some of the most tightly regulated contaminants in foods and pharmaceuticals, but in cannabis, hardly anyone is looking. If you're growing or selling cannabis and you care about product safety, this is something you need to know about. Nitrosamines are a group of chemical compounds that can form during processing, drying, or storage. They're not added deliberately, they're byproducts, formed when certain conditions bring the right ingredients together. Some of these compounds, like NDMA and NDELA, are known to cause cancer, and they're tightly restricted in products like tobacco, pharmaceuticals, and cosmetics. But in cannabis, they're barely on the radar. That gap matters because under the right conditions, nitrosamines can form in cannabis too. In this video, we're going to talk about what nitrosamines are, why they might show up in cannabis, how they're tested, and what that means for you as a grower or seller. Nitrosamines form when amines, which are nitrogen-based compounds found in all plant material, react with a nitrosating agent. In most cases, that means nitrites, which can come from fertilizers, environmental contamination, or even microbial activity during the drying and curing. The conditions that trigger nitrosamine formation are not unusual. Warm temperatures, low oxygen, and the presence of acidic or mildly oxidative environments can all contribute. That means the risk isn't limited to one stage. It can happen during the curing, extraction, or even in the final packaged product if storage isn't well controlled. But not all nitrosamines are equally hazardous, but several are known to be highly toxic. NDMA, NDEA are classified as probable human carcinogens. NDELA is another one of concern. It's monitored in both cosmetics and tobacco because its potential to be absorbed through the skin or inhaled. Cannabis products, especially those that are combusted or vaporized, raise the same exposure concerns. If nitrosamines are present in flower, extracts, or infused products, they can be inhaled directly into the lungs. That bypasses many of the body's natural filters and increases the potential for harm, even at low concentration, which matters when the product is being inhaled directly and often. Most cannabis testing today is focused on what regulators currently require: THC and CBD content, terpene profiles, residual solvents, microbial contaminations, and a defined list of pesticides. These are important, but they only cover part of the risk picture. Nitrosamines aren't part of the standard compliance panels in most labs. They're not being looked for, and in many cases, labs haven't developed the specialized methods needed to detect them. That's partly because regulations haven't addressed the issue yet. Cannabis regulations have moved quickly, but safety limits, especially for inhaled products, haven't kept pace. And while nitrosamines can be measured using GCMS or LCMS, doing it reliably takes carefully optimized methods, specific column choices, and rigorous calibration. It's not something you can bolt onto a routine screening workflow. Now, that doesn't mean the risk isn't there. It just means it's not being tracked. In the tobacco industry, nitrosamines have been a focus for decades, especially a subset known as TSNAs, or tobacco-specific nitrosamines. These include compounds like NNK and NNN, which form during curing and are among the most harmful chemicals found in cigarette smoke. Because of this, they're routinely tested using validated methods developed by CORESTA, the Cooperation Center for Scientific Research relative to tobacco. CORESTA methods typically rely on GCTEA or LCMS setups, depending on the target compound and the sample type. These aren't fringe methods. They're widely used across regulatory labs and industry to meet strict safety standards. In fact, some regions set maximum allowable levels of TSNAs in tobacco products based directly on the CORESTA protocols. The relevance to cannabis is obvious. You've got a plant product, potentially cured in similar conditions, often inhaled directly, but with far less oversight. Nitrosamines don't behave differently just because the plant is different. What's missing is consistent application. The tools exist, the methods exist. They've just not been carried across into cannabis in any systematic way. yet. If you're a grower or dispensary, this is something to think about now, not after the limits are introduced, because when regulation does catch up, and it will, how quickly you can adapt will depend on how prepared you already are. If this kind of breakdown is helpful, give the video a like. It tells us to keep making content that gets into the technical side, not just the headlines. But let's look at how nitrosamines are actually tested. Nitrosamine testing isn't something every lab can offer. The method needs to be highly selective, sensitive to trace levels. We're talking parts per billion, and carefully validated to avoid false positives or misdetections. There are two main ways nitrosamines are analyzed: total content screening and compound-specific testing. Total nitrosamine content, or ATNC, gives you a single value showing you whether nitrosamines are present in a sample or not. It doesn't tell you which ones, but it's a fast way to screen products or processes for potential contamination. This kind of analysis can be run on instruments like the ATNA, or the Automated Total Nitrosamine Analyzer, which is built specifically for this purpose. If you need to identify and quantify individual nitrosamines like NDMA, NDEA, or NDELA, you'll need a speciated analysis. That's typically done using a gas chromatograph like the Ellutia 200 series, paired with a TEA detector, which is the Thermal Energy Analyzer. This setup gives you the sensitivity and selectivity needed to detect trace levels down to parts per billion and confirm exactly which compounds are present. If you're growing, processing, or selling cannabis and you're not testing for nitrosamines, you could be missing a risk. Even if nitrosamine testing isn't mandatory yet, it's worth looking at your own processes because that's where many of the risks start. Nitrosamines don't appear out of nowhere. They form when certain chemical conditions line up, and many of those conditions are shaped by how you grow, dry, and store your product. High nitrogen fertilizers can increase the amount of amines and nitrites in the plant. Extended curing under warm, low oxygen conditions can drive the chemical reactions that form nitrosamines. Storage, especially in sealed packaging exposed to heat, can continue that process long after harvest. And these aren't just fringe cases, they're normal parts of production, which means nitrosamine formation is a real possibility, even in operations that are otherwise clean and compliant. Understanding where the risk points are and making small adjustments early is usually easier than trying to trace and fix a contamination issue later. I'm not trying to create fear. This is about understanding what's in your product and staying ahead of changes that are already coming in other industries. The more you know, the better positioned you'll be when standards change, and they will. We'll cover more on nitrosamines, testing, and regulation in future videos. If you've got questions, drop them in the comments or get in touch. Thanks for watching.